Alright, today we're going to talk about how to solve quadratic equations. We've done a lot of talking about factoring and how we factor, and so now we're going to do a section on how we actually are going to use the factoring to solve equations. So a quadratic equation looks something like this. You've got ax squared plus bx plus c. And the reason it's quadratic is because we have an x squared in there. So a, b, and c are the constant numbers, or the leading coefficient for the x squared and the x, and then the c is the constant number that goes with this quadratic equation. So we are going to be solving some of these, and so we need to know what quadratic equations look like. This one is a quadratic equation. Again, it has the x squared in it. This one is a quadratic equation because if I cleared the parentheses, I would have x squared minus 6x equals 8. That is a quadratic equation because it has an x squared. And then negative 2x squared equals negative 18. Those are all quadratic equations. So a quadratic equation can be written in the form, we have that up there in the box, ax squared plus bx plus c equals 0. And the reason it's a quadratic equation is because equations have an equal sign in them and can be solved. So on these types of problems, we're going to get actual x equals a number, answers, and things like that. So the first thing we need to do, anytime we're going to start solving quadratic equations, we are going to need to have it written all on one side set equal to 0. So ax squared plus bx plus c equals 0. I need all the terms on the left side equals 0. So let's practice doing some of that first. So in order to do this first one, I need to clear the parentheses. So 3x squared plus 3x times 5 would be 15x equals the negative 6. And then I want to bring the negative 6 over with these other terms. So I'm going to add 6 to both sides. So 3x squared plus 15x plus 6 equals 0. So this would turn this into a quadratic equation. And again, on this one, a equals 3. If we want to identify those, they did that in the example, so we'll do that. B equals 15. C equals 6. Okay, this next one, you notice not all the terms are on the side of the equal sign, so I'm going to bring the negative 4x over, so I'm going to add 4x to both sides, and then I'm going to write it in descending order. So the negative 3x squared is going to come first. I'm going to have a plus 4x, and I'm going to have a plus 7 equals 0. So we're writing these equations as quadratic equations, so we set them equal to 0. In this one, a is negative 3, b is 4, and c is 7. And you can't really do that, tell the a, b, and c, unless you put them all on the same side of the equal sign. Now, solving a quadratic equation, we have to use what's called the zero product rule. And what the zero product rule says is that if you multiply and get 0, then one of the factors has to equal 0. Now that may not be exactly how it's stated in the book, but that's pretty much the summation of it. If you're going to multiply two or more factors and you're setting them equal to 0, then one of those factors has to be equal to 0. So in this example, I've got x minus 3, that's a factor, x plus 7, that's another factor, equals 0. So what the zero product rule says is that then that means that either x minus 3, that parentheses has to be equal to 0, or x plus 7 has to be equal to 0. That would make the entire equation on the left side equal 0, if either one of these parentheses turned out to be a 0. So we're going to have to find the numbers that would cause those parentheses to be equal to 0. So I'm going to set each one equal to 0, and I'm going to solve for x. So on this one, I'm going to add 3 to both sides. So x equals 3. On the second one, I've got negative 7 to both sides because I need to cancel out the 7s. So x equals negative 7. On quadratic equations, you most all the time get two answers, two possible answers. So my two possible answers are 3 and negative 7. That would make that entire equation at the top equal to 0 if I used either one of those numbers for x. So when we are solving quadratic equations, let's write down some steps. 1, we need to make sure it's set equal to 0. 2, we need to factor the left side. The one that I just did was already factored. So factor the left side. It's a C there. Alright, 3. Set each factor equal to 0. And 4. Solve. Alright, so this next example, I've got x minus 2 and 5x plus 3 equals 0. So this is already set equal to 0, and this particular problem is already factored. So steps 1 and 2 are already done for you. Step 3 says to take each factor and set each factor equal to 0. So you're making two little mini problems, really, when we do this. Oops, that should be a 3 equals 0. And then solve each one. So in this first one, I'm going to add 2 to both sides. So x equals 2. The next one, I'm going to subtract 3 from both sides. So 5x equals negative 3. And I'm going to divide both sides by 5. So x equals negative 3 fifths. So my two answers are 2 and negative 3 fifths. Not so bad. Okay, now let's look at some other types of ways we could see factors. This next one, I've got a 10x on the outside and a 2x plus 5 on the inside. So this looks to me like when we factored it, then we factored out a greatest common factor. So not all the time are you going to have two parentheses in these to be able to set equal to 0. Sometimes you may just have one term. Now, we're going to, in order to be a factor, so let me write this down. To be a factor, you need an x with it. Okay? So in this next problem, I've got a 10x and I've got a 2x plus 5. So the two factors are 10x, and we'll set it equal to 0. And then I'm going to set 2x plus 5 equal to 0. And I will solve each one. So on this one, I divide both sides by 10. So x is 0. There's an answer. There's one of my answers. On the next one, I'm going to subtract 5 from both sides. So 2x equals negative 5. Divide by 2. So x equals negative 5 over 2. Okay, so there's my two answers, 0 and negative 5 over 2. Now the next one that's sitting next to it, let's look at it. I see a 10 on the outside, a 2x minus 1, and an x plus 5. Now what's different about this one is that the 10 on the outside does not have an x with it. So if we think about this, if I wanted to try and set that equal to 0, does 10 equal 0? Well, no, it does not. That doesn't make sense. So the 10 in this particular problem just doesn't really matter as far as solving the quadratic, solving the equation. So I'm going to take the factors that have the 0 in them. 2x minus 1, we're going to set it equal to 0. And we're going to set x plus 5 equal to 0. And we're going to solve each one. So I'm going to add 1 to both sides. So 2x equals 1. And divide by 2. So x equals 1/2. There's an answer. And then on the second equation, I've got x plus 5. So I'm going to subtract 5 from both sides. So x equals negative 5. So two answers, 1/2 and negative 5. Okay, let's see what some other examples might look like. Alright, so here's one where we're trying it. And you can see at the top, I'm looking at the one on the right hand side. I've got a 3, an x plus 2, and an x plus 5. So again, the 3 does not have an x with it, so I don't really have to, it doesn't come into play at all. So I'm going to take the x plus 2, and we'll set it equal to 0. I'm going to set the x plus 5 equal to 0. Now, I want you to solve those. I'm going to give you a minute. Maybe not a full minute, but I'm going to give you a little bit of time. I want you to try and solve those. And let's see if you get the same answer that I'm going to get when I solve them. I'll give you a few seconds to get that one started. Alright, on this first one, I hope that you subtracted 2 from both sides and got x equals negative 2. And then on the second one, I hope you subtracted 5 from both sides and got x equals negative 5. So there's my two answers. Alright, so far we've had ones that have been factored. So of course you know you're going to have some that are not factored. So the next one is one of those. Now I see that right away this one is not set equal to 0. So I need to move this 12 over so I can have x squared minus x minus 12 equals 0. So now it is set equal to 0. So that was the very first step. Second step was factoring. So I need to find factors of negative 12 that add up to negative 1. And so that would be a negative 4 times a positive 3. Negative 4 times a positive 3 adds to get a negative 1, multiplies to get a negative 12. So if I'm going to factor this, I'm going to have an x minus 4 and an x plus 3 equal to 0. And now that I've got my two factors, I split that up and I take each factor, set it equal to 0, and solve for x. So I'm going to add 4, and then I'm going to subtract 3 on this one. And there we go. We've got two answers, 4 and negative 3. So sometimes you're going to have to do a little bit more manipulation than just have one that's already factored for you. This next example at the bottom of the page, same way. I've got this 15 on the right hand side. I need to move him over by subtracting 15. So that's going to give me x squared minus 2x minus 15 equals 0. And so to factor that, I need to find factors of negative 15 that add up to a negative 2. So those would be negative, let's see, negative 5, positive 3. That's going to give me a negative 2 if I add them. It's going to give me a negative 15 if I multiply them, so that would be right. So x minus 5. Now it may be taking you a little bit longer to figure out those factors because we haven't been factoring a real long time, and so you may need to be making an entire list like I've done in earlier videos, making a whole list for 15, although 15 you've just really got 5 and 3 and 15 and 1, but you may still be doing that, and that's just fine. You are still in the process of getting a hold of factoring. So I've got x minus 5 equal to 0. I'll set that one equal to 0. I've got x plus 3. I'm going to set it equal to 0, and I'm going to solve each one. So I'm going to add 5. So x equals 5 for one answer. Subtract 3 on this one. So x equals negative 3 for this other answer. So 5 and negative 3. Alright, moving right along. Here we have one. 3x squared plus 21x equals 0. Nice thing about this one is it's already set equal to 0. That's the first step. So the next step would be to factor. Now, do not assume that because I have two terms, it's going to be perfect squares. Remember, go back to the steps in factoring. Always look for a GCF first. So on this particular one, I could factor out a 3x, and that would leave me an x plus 7 in the parentheses. So you can see I've got two factors here because I do have an x with that 3. So I'm going to take 3x, I'm going to set him equal to 0. And I'm going to take x plus 7, I'm going to set that one equal to 0. So on this first one, if I divide by 3 on both sides, I still get 0 for an option. So there's an answer. On the second one, I'm going to subtract 7 from both sides and get a negative 7 for my other answer. So you're not always going to factor by finding factors of the last term that add up to the middle. Sometimes it's a GCF. Now this next one, you've got x squared minus 9x. This is not set equal to 0, so the 9x needs to be over. I'm going to subtract 9x from both sides. So x squared minus 9x equals 0. And so, yes, 9 is a perfect square, 3 times 3, but I have an x with it, GCF. Take out an x first. That leaves me with just x minus 9. So I don't factor difference of squares because I took out a GCF. So in this one, there's nothing to work on this first part because I'm just taking x and setting it equal to 0. I don't have to divide by anything because it was a 1x. And then x minus 9 equals 0. So we're going to add 9. So x equals positive 9. 0 and 9. Those would be my two solutions. Now, these next ones are going to be a little bit tougher. And the only reason they're tougher is because they have really put things that are factored, but you have to really FOIL them out first because I've got this 4 minus 2x on the other side. So remember, I need everything set equal to 0, and I can't just bring 4 minus 2x over and do any subtraction because I've got factors already over here. So I'm going to have to FOIL this out. And you won't see many like this. Most of the ones you're going to see are ones that you need to move a number over and then factor, or you'll have some that are already factored. But every so often you're going to come across one where you have to FOIL it out and move things over and then factor again. So 2x times x would be 2x squared. Outer times outer, 2x times a negative 2 would be negative 4x. Inner times inner, 1 times an x would be a plus 1x. Last times last, 1 times a negative 2 would be negative 2, equals the 4 minus 2x still. Didn't do anything with him. So let's combine these middle terms. 2x squared minus 4x and a minus 1x is negative 3x minus the 2 equals 4 minus 2x. Now I'm going to bring the 4 minus 2x over. I'm going to subtract 4 from both sides. That moves this 4. I'm going to add 2x to both sides. That moves the 2x. I did that all at once, so I'm hoping that doesn't confuse you. Go back and rewind it and look again if that confuses you. Negative 3x plus 2x gives me negative x. Negative 2 and a negative 4 gives me negative 6 equals 0. Now, I have gone through and made that into a quadratic equation set equal to 0. And so I did have to FOIL, and then I had to go to my steps. So you may have a couple that you have to do like that. Now, to factor this one, it's not just a 1x squared, so I'm going to have to think about this. I'm going to do AC method. 2 times negative 6 gives me negative 12. I want to multiply to get negative 12, but I want to add to get negative 1. So I need to think about factors. That would be, I think, a negative 4 and a positive 3. Let me check it. Negative 4 times 3 is a negative 12. Negative 4 plus 3 is a negative 1. So that works out. Now I'm going with AC method, so I'm going to have 2x squared minus 4x plus 3x minus 6 equals 0. So we've done AC method. You know, that's where you turn it into a grouping problem. So now we're going to group each one. For 2x squared and 4x, I can take out a 2x, and I'm going to have an x minus 2 left. For 3x and 6, I can factor out a 3, so I'm going to factor out a 3 and have an x minus 2 left, which is good because remember, in grouping, I need my parentheses to match at this point. So then my parentheses are going to be the x minus 2 and the 2x plus 3. And those are set equal to 0. So now that's factored all the way. So I'm going to come over here and I'm going to take x minus 2 and set it equal to 0. And I'm going to take 2x plus 3 and set it equal to 0. And solve each one. So I'm going to add 2. So x equals 2. I'm going to subtract 3 on this other one. So 2x equals negative 3, divide by 2. So my other answer is x equals negative 3 over 2. There would be my second answer. Alright, so I'm going to do one more like this, And then we're going to do a few of your favorite word problems, because I know everybody loves word problems. We're going to do two different kinds. So here's one, solving the equation. This one's not as rough as the other one that we just did. This one, again, it's not set equal to 0, and I can't just bring the 6 over because I've got parentheses factors over here on the left side. So I need to FOIL this out. X times x is x squared. Outer times outer is a plus 3x. Inner times inner is a minus 4x. Last times last is a minus 12 equals my negative 6. So I've got x squared minus x minus 12 equals negative 6. Now move the 6 over. So I'm going to add 6. So x squared minus x minus 6 equals 0. This one's a little bit easier to factor because I don't have to do the AC method. I can just find factors of negative 6 that add up to a negative 1. So that would be negative 3, positive 2. And then we're going to make our factors in our parentheses. X minus 3, x plus 2 equals 0. And then split them up. I'm running out of room, so x equals 3 for this one, and then x plus 2 equals 0. We subtract 2, so x equals negative 2 on this one. So my two answers are 3 and negative 2. So those will be really the one where you have the most steps if you had to FOIL out before you could move things over and then factor. Alright, so I'm not going to work some of these really longer ones because we're not going to have any that are that long. I want to move over to some word problems. And I want to do a couple of different, just two different kinds of word problems. I want to do consecutive integer problems, and then we're going to do area of a rectangle problem. So, consecutive integers. If we talk about integers, just regular integers, if they are consecutive, that means like counting, like pages of a book. It would be like 1, 2, 3, 4, 5, so on. Those are consecutive integers. Alright, consecutive even integers, let's think about that. That would be like 0, 2, 4, 6, 8, and so on. When I'm looking at consecutive integers at the top, to go from 1 to 2, I'm adding 1. To go from 2 to 3, I'm adding 1 again. To go from 3 to 4, I'm adding 1 again. Now to go from even integers, from 0 to 2, I'm adding 2 this time. 2 to 4, I'm adding 2. And so on. If I were doing odd integers are like 1, 3, 5, 7. And incidentally, you could have negatives over here. I could have had negative 1, negative 3, negative 5 on down. But those are going on and on. And look at odds. 1 to 3, I'm still adding 2 because you're skipping each time. So odd integers, I'm adding 2 each time as well. So even and odd are going to be worked the same way. It doesn't matter which way you're asked. So in this particular problem, it says the product. So product means to multiply. Of two consecutive even integers is 48. Find the integers. Well, I'm going to let x be my first integer. And so, if x is my first integer, the next even one, I'd have to add 2 to it. So x plus 2 is going to be my second integer. And this one says we just have 2 of them. If I had 3 integers, I would have done x plus 2, which would be x plus 4. But we just have 2, so we're good to go. Now it says to take the product of these. So x times x plus 2. The product is equals 48. And now you see it looks kind of like a problem like I just did. I'm going to have to clear my parentheses before I bring the 48 over. So x times x is x squared. X times 2 is 2x equals 48. Now bring the 48 over, so subtract 48. So x squared plus 2x minus 48 equals 0. Now it's ready to factor. So factors of negative 48 that add up to 2. That would be, let's see, a positive 8 and a negative 6. They multiply to get negative 48, but they add, I would subtract them to get 2. So x plus 8 and x minus 6 equals 0. Let's solve each one. So x plus 8 equals 0. So subtract 8 from both sides. So x equals negative 8. And then x minus 6 equals 0. Add 6. So x equals 6. Now it asks for each integer. So if I've got negative 8 is one of the consecutive even ones, then the next one after negative 8, if I'm thinking across the number line, would be negative 6. So negative 8 and negative 6 to go together. For 6, I go add 2 more. So 6 plus 2 would be 8. So 6 and 8 work. So these two work together and these two work together. So you've got 2 sets of answers on this one because I had 2 sets of numbers that could multiply and get me 48. So if an integer is represented as x, if I can speak right, how would you represent the next consecutive? That would be x plus 1. For evens, the next integer would be x plus 2. For odds, the next one would be x plus 2. So that's how you do an even and an odd integer when we multiply. Okay, let's go to the next page and we're going to do a rectangle problem. So the area of a rectangle is 240 yards. The length is 8 yards longer than the width. Find the dimensions of the field. Anytime I'm given a problem like this where I can draw a picture, I'm going to draw a picture. So there's my rectangular field. Okay, so on it, it tells me that I know that my length is 8 yards longer than the width. I don't know anything about the width, so I'm going to let it be W. And I know that the length is 8 longer than the width, so that would be W plus 8. Now, we need to remember that the area of a rectangle is length times width. So in this one, my length times width is going to be equal to 240 because that's my area right there. So I'm going to write it as, sorry about that, W times W plus 8 equals 240. And you can see it looks like one of the equations that we've done so far. I need to clear my parentheses before I move the 240 over. So W squared plus 8W equals 240. We're going to subtract 240 from both sides. So W squared plus 8W minus 240 equals 0. So to factor that, I need to find factors of negative 240 that add up to 8. And in the essence of time, I have already done that. The two factors are 20 and negative 12. So I'm going to come down here. W plus 20 and W minus 12 equals 0. So W plus 20 equals 0. Subtract 20. So W equals negative 20. Then over here we've got W minus 12 equals 0. Add 12. So W equals 12. Now, the only answer that makes sense is the 12. You can't have a negative width. It just doesn't make sense. So W is equal to 12. So then my length is 8 more, so W plus 8 would be 12 plus 8, which would be 20. So my width is 12, my length is 20, and that's how you would do a rectangle word problem. So I just did 2 examples of the word problems. If you need to see more, feel free to email your instructor or email me, and I can do you some more, but you can rewind this and see they're all worked similarly, so it's very easy to do. If you have any questions, please be sure and get in touch with us. Have a great day.